There are two key ways to make ethers that I want to talk about. One is much more widely used than the other, so let's talk about it first. The approach is used when one of the alkyl groups attached to oxygen can come from a primary halide. The approach involves making this target from two pieces, one that comes from an alcohol, shown here as an alkoxide, and the other from an alkyl halide or tosylate. This is an SN2 reaction, so we picture a pair of electrons from oxygen making a bond to carbon as the halide is displaced. The leaving group can be chloride, bromide, iodide, or tosylate. Let's take a look at some specific examples. When methoxide is put together with an alkyl bromide, we make a methoxy ether. Here's the new bond. The alkoxide can be one of a variety of things, including things that are very hindered, unlike the alkyl partner, which must be primary. So here's tertiary butoxide. There's 3 methyl groups here, remember? So this is bulky, but it's unimportant. Reacting with the same alkyl halide, we'll get good yields of the ether. In theory, this molecule could be made by putting together a different alkoxide and alkyl halide, using the tertiary alkyl halide and the primary alkoxide. But because this is an SN2 reaction, this tertiary halide does not react. This will result in no product. So remember, when you're looking at the two possible alkyl partners to make ethers, make sure that the bulky side comes from the alkoxide and the primary side comes from the alkyl halide. You can even use nucleophiles that have an aromatic ring attached to the alkoxide oxygen. This will provide good yields because the displacement of the SN2 reaction is occurring at a primary center. So we can make ethers from primary alkyl halides and tosylates in good yields as long as we make sure that it's the primary alkyl group that's undergoing displacement, and a wide variety of alkoxides can be used. That's the key way to make ethers that have primary alkyl groups attached. Let's take a look at the case when they have tertiary alkyl groups. This is very different chemistry. This is an SN1 reaction. It's a tertiary alkyl halide. The leaving group can be chloride, bromide, or iodide. Using a protic solvent that also is a good nucleophile, like methanol or ethanol, you can make tertiary ethers directly from the alkyl halide. Choose methyl alcohol to get the methyl ether, choose ethyl alcohol to get the ethyl ether. This generally is limited to reactions with small alcohols that also can be used as solvent. And you might wonder about the synthesis of ethers that oxygen is attached to a secondary carbon that would come from a secondary alkyl halide, and I have to tell you that those are not made in good yields. And we'll really focus on compounds that could come from primary alkyl halides or that could come from tertiary alkyl halides. In each case, the reaction choices are clear. For the primary alkyl halides, we'll use an SN2 reaction, and for the tertiary alkyl halides, we'll use an SN1 reaction.